Corné, I think typically you like to get through your slides and then have questions at the end. Is that correct?
Yeah, I think let's try that. But
Okay.
if there is a burning question, I'm happy to field them in
All
the
right.
middle. But
Okay.
Howard, maybe you can just
I'll,
look
I'll
at the
monitor
chat.
that. No,
Thank you
no.
very much. But yeah,
I just need to keep Renko in line because he typically goes, he has a lot of
no, and
questions. So.
I think I can also mute.
What did I
I
do
think I can
wrong?
also mute participants.
Okay, fantastic.
Okay.
But thanks,
All right. So
everyone. Thanks, lovely to see Shane and Mark Nolte and all the people that we haven't seen. I feel bad mentioning a few, but it's really nice to see the foreigners in. Guys, thank you so much. And Corné, thank you for sharing again. It's lovely to see everybody back online again. All yours, Corné.
thanks, Howard. Yeah. So today I'll be going through a specific example that I deal with a lot, and I thought it would be a good opportunity to kind of share what I see, how this example is implemented in kind of a traditional warehouse sense, but especially with the focus on data mesh and data contract. And I think what you've mentioned on your Thursday talks, like making sure the framework is ready for AI, I feel like this talk maybe would even fit better under that category, because I think
No, it's okay.
a lot of the content will be associated with that. So I'm going to start with the end in mind, and I'm going to kind of show you what are we aiming towards. Okay, so I don't think any of us know exactly where AI or how it will affect our daily lives in the next 5 to 10 years, but we know it will be quite a substantial impact. So there's no running away from it. And I think what we're seeing in the industry is that AI architecture and kind of structuring your data and data products to make it more reliable for things like large language models, etc., is going to become quite important. So, what I'm going to end off, we're going to dive into a bit more detail with this demo at the end, but I'm going to just kind of start with where I want to end. So if I am the CEO of my online toy store, and I want to understand what products are we selling online, I want to be able to, for example, interact with a large language model that will go into my data catalog and query products that we are selling online and giving me some description and a little bit of an analysis on what they are. Okay, I'm not going to dive into that detail now. For now, I'm interested maybe just in, like, every morning, I want to know what are the most visited products on our websites in the last 2 months. It's quite funny to see the LLM interact, because it's sometimes, I've tried this about 10 times and its behavior, 9 out of 10 times it's exactly what I want. And 1 out of 10 times it does something different. But I think it's doing what I was hoping it's doing. It's finding a marketing leads metrics and saying that, oh, okay, looks like there's a fact table that might be interesting, and it's running a query and it's giving me the information that I wanted. So these are the top ranked visited products on our website with some metrics, and it's doing this by querying the data catalog with the context that I've given it. And that's kind of where I want to end off today. So I'm going to pause the demo there. I'm happy that it gave me a bit of the it's also interpreting, obviously, some of the data that it's seeing. It's saying that this Dino Figures is the clear leader with 13 visits, and what's coming in second, and it's kind of trying to interpret some of the data on its own. So what do I want to talk about today? Going from a monolith to a contract-driven mesh. Let me just find my... So a little bit about me. I'm a data architect, freelance data architect for Sparkle. Sparkle is a Belgium-based data consulting company. So I do most of my work at the moment in Europe. Obviously, I live in South Africa. I'm a Cape Townian. I'm also a paddle injury statistic, recovering paddle injury statistic, hopefully, very soon. I also like to write about pragmatic approaches to data architecture, so finding the right balance between purist and practical. I'm quite averse to making absolute statements with regards to there's only one way of doing something. I really believe that every scenario or everything is case by case, or it depends, what your organization is going through, what might be the correct data architecture for you. I spent quite a few years in Data Vault and designing template-driven or using template-driven designs for data warehouses. And I've been involved in 2 long-running data mesh or mesh-like projects. So you can find me on LinkedIn and also view a few of my articles on Medium. So today I'm going to break it up in the following. I'll have a few slides on what are the words that we are talking about today. Why do I use the term monolith versus, and what is data mesh, or how does that contrast, as well as a focus on data contracts. So the example that I started off in the beginning, so analyzing website traffic, this is an example that I deal with currently on a day-to-day basis. Without data mesh, so how you typically implement this in a more centralized implementation approach, whereas how does it work, or how do I see it being implemented within a data mesh, and also adding some of my observations or some of the challenges that I see with data mesh, or maybe just the things that one needs to be cognizant of. Then a slightly deep dive into data contracts, what they are and what makes them so special. And then how does all of this fit into the modern landscape? So third-party tools and AI, large language models. So let's start with a few definitions. So why do I use the term monolith? The monolith, as the term suggests, where it's one centrally owned data warehouse or centrally owned architecture, which started in IT, and it's probably grown into quite a monolith. So a central team that owns everything. It owns the ingestion, the modeling. How do we model? How do we transform data? How do we do data quality, etc.? A centralized data architecture. Maybe for whatever reason, it started off with very tightly coupled components, and it's kind of grown into a bit of a monster. Slow change cycles. So if teams or business wants to see new requirements built, there's quite a big backlog. And limited domain context. So this is something I see often in monolithic implementations, is there's quite a long cycle or let's say a big gap between the requirements and the understanding from the domain inside the business to IT, where it actually gets implemented, or the central team that implements it. But obviously this has some scaling problems. As more data arrives, more teams wants to do, and these days more so than ever before, teams want to do AI workloads. So either kind of classical machine learning to AI agents. That's something I see. I'm not necessarily commenting on whether I think it is adding value at this stage, but every team wants to build some sort of a AI bot or something, and this requires obviously data to be made available. So this kind of monolithic approach is difficult to scale, especially at the rate at which business wants to add features and functionality. So monolith is kind of a contrast to data mesh. Data mesh is a centralized approach to data warehousing. I'm not going to go into detail of what data mesh is. I've had a few, I think that's probably a 20-minute deep dive that would be required. So I'm assuming some sort of understanding of what data mesh is. So apologies for those who do not know. But the 4 main pillars is probably the thing you have to remember now. It is the corners, the 4 main pillars on which data mesh is built is domain ownership. So a decentralized approach where these data products get owned by the domain in which they are built. Data as a product. So in other words, there's product thinking. You have a life cycle is associated with a product, and everything that you would associate with a product, just like any product that you sell, you kind of have to have that same mentality with data. Self-serve platform. So you want the domain teams to be able to help themselves really come to a catalog, request data, and be able to build their own data products. Federated governance. So you want to be able to set policies and rules at a global level, but you want to be able to make it available to the domain team so that they can implement those policies autonomously, so that the governance team doesn't become the bottleneck, but it's federated to the different domain teams. So data mesh, connected network of domain-owned data products, not one central warehouse. I want to add a specific mention on data contracts here. So what are data contracts? So the idea evolved from API contracts or API specifications, which has been around in software engineering for almost forever. The term data contracts got popularized due to the coining of the phrase data mesh in 2019, or when Zhamak Pengani came up with the idea. It borrowed a lot of software engineering principles, and the term data contracts became popular around 2021, 23. Some of the key early promoters were Chad Sadnerson is someone that still is quite active on LinkedIn, Gable.ai founder, Andrew Jones, a UK-based data engineer who also wrote a lot of blogs and had talks about data contracts, and he wrote a book about it in 2023. And there's also now an open data contract standard, which I will dive into a bit of detail at the end, which is an open source framework for data contracts. Howard, I will see a hand, but I'm not sure if there was a question posted.
Yeah, do you want to take it now, or should we postpone it to the end? I did mention in the chat that we'll leave them to the end.
Let's maybe I'll wait for maybe a more
okay.
Natural gap.
It's fine, Howard. Actually, I'll make a note of the question
Okay,
I
great.
wanted to ask. Okay.
Thank you very much.
Thanks. I wasn't sure that I can interrupt. Thanks.
I guess you can, but maybe if I can maybe just get through a few more slides and then we'll take them. Okay, so where does data contracts fit into data product architecture? This is a picture I'm going to use quite often in this session, so I'm going to go a bit slower through it. Just to kind of understand the different concepts and how they talk to each other. So in data mesh, a data product is owned by a domain. A domain can own multiple data products. A data product has different types, or there's a data product is of a certain type. I guess this is debatable. I wouldn't say there is a fixed list of data product types, but these are the three that I see widely used. They have slightly different naming, but you have the kind of source aligned or raw data products, which is more like a one-to-one with your raw source, and foundational or aggregate data products, which is to be reused within the organization. So they are not really built for the end consumer. They are built for like building blocks in your organization. And then you have consumer data products, which uses either the raw data or it uses these building blocks to build something for the end consumer. A data product has input ports, so that's let's call it the port for how data gets inserted into the data product, and data product also exposes its data into one or more output ports. And the data contract governs the ports, or the output ports to be more specific. It does not govern the data product. So the standards that I will be going through is where you specifically have data contracts governing the different types of output ports on that data product. Okay, so I'm going to come back to this picture quite often, but I think this is a good starting point to understand where data contracts play a pivotal role in publishing your data products within your organization. So next, I'm going to illustrate explain the example that I want to use when I'm going through these different steps. And this is an example, as I said, which I deal with quite often, at least in my current role. And it's website analytics. So assume, or just imagine yourself on a website and you want to order a product online. In this example, it's an online toy store. Whenever you go to the website, you get annoyed by those cookie pop-ups. So when you allow for when you say accept, I'm not sure if you always think about what you're doing, but when you say accept, that means that depending on the settings, but there's some default settings, the tools that this data layer of the website feeds into is now allowed to track you, and it stores a identifier associated with your device and your browser. So if you once you've accepted the cookie, you are seen as a visitor. You will have either one or more sessions. So when you return, so when you say you switch off your laptop and tomorrow you come back on the same website, that's your visit number 2, and that's a second session, provided that you accept the cookie again. So each session is associated with a device, so your mobile device or a laptop, and each session is also associated with a browser, Google Chrome, Edge, and each session has multiple possible events that you can do on a website. So even if you just hover your mouse, those are also events that can be tracked. So basically, once you've accepted the cookie, all of those behaviors can be tracked, what you are doing on the website. And an event can be associated with a product. So obviously, let's say you're just on the main screen of a website, you're just browsing, clicking around. That's not necessarily associated with a product. But once you click to the sub pages and you go to the order, or you go to a page that's specifically about a product, then it becomes associated with a product. So this is a simplified version of the model, of the data model, but I think it illustrates the point. And I find it quite interesting because I see all of this behavior, and it's quite interesting what you can do with this data. So let's take the example where the marketing domain wants to be able to track what they call marketing leads. So a marketing lead could be for them, I'm going to make up some examples. It could be if you came to the website via a Google Ads. So when you search for something and the Google ad at the top was something that you paid for, if they click through that and maybe you fill in a form on the website, that event could be seen as you are now a marketing lead, and they want to be able to track these metrics. So the job that needs to be done is you have to go from this kind of operational model. And this is, let's say, in some tools, pretty much how the data is stored as well. You have to go from this operational, obviously, a lot of high frequency data, depending on what your, of how many products you sell or how many thousands of customers you have online. And you have to kind of sift through that now to give an analytical view of this data. So the hard work is really turning all of the information between the session and the event and turning it into your fact table. So I've already kind of assumed that we will go with a dimensional model here as your analytical output, because this is still what I see 95% of the time practically being built in the industry. So your data engineers need to go and figure out, how do I use the session and event information to track how many leads are being built? But you really need domain expertise or domain knowledge to understand how we're going to calculate these marketing leads. So how does one do this? Maybe at that point, maybe I can quickly take 1 or 2 questions if it's still relevant. Otherwise, I will wait till the end.
Okay, Johan?
Howard, okay, maybe I should wait until okay, because I did post and it's more of relevance towards the data contract and data vault. So let's not actually confuse it with what you've done here.
All right,
perfect. Thank you. All right, so let's take this example and just shortly explore some options how you would do it without data mesh. So I'm going to use the medallion architecture as an example, and just go through the different layers on how you could potentially implement that. So by no means this is going to be a detailed example. The detail will be a bit more on the data mesh side. With this one, I just want to mention a few possible alternatives. So if there are any data vault or 3NF disciples in the room, please do not throw stones at me. But yes, so Google Analytics has a kind of more of an API endpoints, and basically what you have is this very massive nested JSON, which kind of simulates the structure that I showed in that operational model. You have the events, the sessions, the visitors, and so on. And whatever you configure, you can really capture. Whatever you've configured on your website, you can collect that information. But just assume it's a massive nested JSON file. Adobe Analytics, and also assume that you have both of these tools. These are two tools that I work with, so I use them in my example, but obviously there are more. Adobe Analytics is a bit older solution, so it has a bit more archaic architecture, and it has for example, a raw data feed option where it extracts something like hundreds of columns in a very flat CSV file. Okay, so your data engineers has the job of extracting this data from the API as well as the Adobe Analytics. For Google, you have a visitor and the events. And for Adobe Analytics, you have this large CSV file. So how you would implement this is following the medallion architecture. You store the raw immutable data exactly as it was produced. So you could have a staging layer where you just publish these nested JSON and large CSV files, and you call it your bronze layer. In the silver layer, which will be your clean, modeled, and source agnostic layer, you will start to combine these data sets because essentially they track the same thing. They have different pros and cons on what they can and cannot do. But assuming you have both of these tools, you want to combine this in some sort of meaningful way. So here you can obviously decide to use whatever modeling technique you want. I'm not going to go into the detail of each one, but you could be building a data vault or a third normal form, or you can decide we want to reinvent the wheel and build something ourselves. And then at the gold layer, you are publishing basically this curated, aggregated, and built for the consumer models ready to be used by your domain. So the marketing domain told the centralized team, this is what we want. The centralized team went away and built these different layers within the data warehouse, and they published this dimensional model for your perusal at the end. And you would connect your Power BI or whatever other tools you want to this final gold layer. Just putting a little bit of a different flavor on it. Obviously, there's many iterations of this, and I have seen really many iterations, and almost all of the time they are very similar in like the structure. They're just called different names. So if you want to build like an enterprise data warehouse, again, data vault, potentially a raw data vault, business data vault, and you have your information marts published at the end. Again, typically I still see dimensional models as the go-to for your final analytical mart published at the end. So from experience, I luckily don't see too many, let's say, strange variations. I do see quite a lot of data vault implementations these days, more than I did about 5 years ago. I won't comment on whether I think it was a good data vault implementation, but that's what I see. So I think that's about as far into detail as I want to go into. Shane, I absolutely agree with you. I saw just your comment on saying Medallion is not an architecture. I 100% agree with you, and I think let's not go into that debate. But it is still labeled as Medallion architecture in many online resources, so that's why I used the term. But I agree with you. It's just a kind of a logical split. It's not really a physical model. It will still always follow these kind of traditional data warehousing or data modeling techniques. Okay, so what I want to get to is more what next. So what often happens, and I make a bit of a joke about this, but it's actually what I also see. So there's some managerial changes. You've been building your data warehouse. It's working beautifully. There's some management changes, and they're saying they're moving to data mesh. Why are we moving to data mesh? Well, maybe the CDO got cornered by some vendors at a data conference, and they persuaded the CDO that data mesh is the way to go. And your entire team now has to go through quite a bit of a change management to adhere to this. Now, I said this a bit tongue-in-cheek because I do believe there are some very good benefits to data mesh. I don't think it's for everybody. It really depends on the culture within your organization. But I want to make the point or illustrate the point that most decisions, or you cannot necessarily preempt why some of these decisions are made. We as data professionals often enter a company And those decisions have already been made. And we have to kind of live with those decisions, and we can question the decisions and try and reverse them, but it doesn't really matter often how we got there or why we are there. We are often already in a position we have to make do with what is there, and we have to kind of slowly change the machine towards something that is more workable. So data mesh is obviously a very big organizational shift. So often there would have been a very long decision process that actually decided that an organization needs to move to data mesh. Typically, it is large organizations. The two long-standing projects that I've been working on is typically very large organizations which has a federated nature to it. So they are broken up into large departments, or they have subsidiaries, and then it does make sense. And it's on this point that I want to zone in a bit, saying where I think data contracts will make a valuable difference. So this example that I just showed, how can we implement it using data mesh? So the website analytics, I would say we have two, and this is now really from experience that I want to tell you the observations that I often have and where the challenges lie. Most of my debates is around this topic. Do we do the first option where we say, let's rather build foundational or these building blocks that we can reuse logic and not have every team have to rebuild their own data products using the exact same logic. So let's build a foundational data product on the website analytics data and another foundational data product on the product catalog, and then have each one of the consumer data products use the data from these building blocks. And that way you can have a standardized model, so not rebuilding the logic yourself, and you could have standard consumption patterns. So conceptually, it makes more sense to do this so that you have reusability and you don't have every team trying to do it themselves. Now, the big problem with this approach is who owns these foundational data products. And this often is why I would say domains or business domains realizes why IT existed in the first place, because they do not want to understand necessarily CI/CD and different maintaining different versions and all of the technical jargon that goes with maintaining a product. This is something that used to be outsourced to IT. IT can manage this, but now if you have these foundational data products or building blocks in the middle, domains or business domains really needs to own this. So your marketing domain or your customer experience or finance actually needs to own these foundational data products. And that's where it gets tricky, because they do not want to own it, or they do not want to actively own it and actively maintain it. So alternatively, you could say, okay, well, whatever, we don't want to do that. We just want the consumers to rebuild their own data products on the raw data all of the time, even if it means duplicating it. And most of my discussion is around this. And the decision is never really made, what's the best choice? It's really, do we have ownership for these foundational data products? Do we have budget for building these foundational data products? In most cases, it's about budget and resources. It's not about, do we think this is the right approach? We do think this is a better approach, but too often we end up having teams building their siloed data products on top of the raw data because it's quicker. The teams remain autonomous. That being said, I'm going to use the top one to explain how to implement the example that I shared previously. And what we will do is we will have a foundational data product called website user behavior, utilizing the data from Google and Adobe and joining them and publishing them as a shared foundational data product. We will have a product data product from the product catalog, and then we will have the consumer data products using the data from these foundational data products rather than having these three consumer data products all reading the source data themselves. So back to this picture. So the foundational data product called website user behavior, just extrapolating it. So we will have a data product called user behavior. This is a foundational data product. Ownership is important. This should be owned by the customer experience domain in my example. And we have two input ports. So I'm just putting data mesh terminology over this, but it's just the API specification, for example. So it's not something new that we're reinventing, but it is just using the raw source data as our input ports. Then we say we'd like to publish our user behavior in three different ways. We want, let's assume we are building on Snowflake. So one of the output ports will be Snowflake tables. Then we will have an API endpoint, and then we will have some iceberg tables as well. And each one of these will be governed by a data contract. The consumer data product is called marketing leads conversion metrics. It uses the previous slides foundational data product as an input, and it publishes its output on Snowflake tables as well as an API endpoint. So same example, basically the same screenshot as before, but using data mesh terminology. What is the difference? The difference really is ownership. So the ownership and the purpose that it gets used for. So the foundational data product is built for reusability. The API inputs can be treated as input ports. You have a contract on top of it, and you publish the output, and you also have a contract on that. I will get to some detail about the data contracts in a while, but just kind of conceptually explaining it for now. So as I said, it's built for reusability, and the modeling technique that you use in the data product will be largely driven by reusability. You can still use Data Vault or whatever modeling technique you are interested in, but this will be decided and owned by the domain that owns this data product, and it is driven by reusability, not for end user consumption. So in my experience, let's go back one slide. I also see multiple different methods being used here, Data Vault or even dimensional. I would argue that a dimensional fact table and fact and dimension tables shouldn't be used here because you're already kind of building it for an analytical fast output, like you want to build a Power BI report or something on top of it, but be that as it may, that is what I see. The consumer data product is then using this normalized Snowflake tables from this data product as an input. And this one is specifically built for the use case for the consumer. So again, you can use whatever modeling technique the domain decides to use, but this will be driven by what is it built for? Because it's a consumer data product, it is really for that last step in the process. What do I want to build this for? Is it for some machine learning algorithm, or is it for a Power BI report? So that is driven by the consumer's requirements. And let's say our output port is some iceberg tables because we want it to be interoperable with different technologies. So let's say we built this within Snowflake, but we want to publish it as an iceberg table so that it can be utilized by other tools, not just within Snowflake. So just kind of mapping it, input ports, the data product, and the output ports, and its governing data contract. Okay, so just a short focus on data contracts. While I do that, just let me get a sip of water. Okay, so, oops, wrong direction. Okay, so what is a data contract? for me, I think it should be seen purely like any paper contract that you have to sign with anyone, if it's with your tenant, or it really is it's a contract between the consumer and the producer. As a producer data product, your contract is where everything that you will adhere to is being written, and as a producer, and your consumer can then read that contract and know what is your legal obligation, but your contractual obligation as to what you will be producing. So it's kind of just think of it as any normal contract. Technically, what is it? It's a lot of YAML files, and it is based on, there's a couple of standards. There is a open data contract standard that was produced by the Bittle project, or a Bittle open source project, and there is some vendor-specific ones as well. I'm going to show you a little bit about the open source one. So from some of my colleagues in the industry, it's the feeling I get is that this one will become the kind of the industry standard. I saw recently that Calibra has also now adopted this open data contract standard. I think it's still in private preview, but they are looking at using it. So for me, that's good news. If there's one standard you can work towards, then you can build tools on top of that standard, and there's a lot of reuse in the market. So this is a little bit of an example of what the standard looks like. So it is based out of 10 different components. I'm just going to show a few of them, not everything, but some fundamentals. So assuming this user behavior data product that I've published as a foundational data product would have a name, who is the owning domain, some descriptions. So there are a list of optional and mandatory fields as published by this data contract standard. Schema information, so this would be all of the technical details of exactly what fields are available. Yeah, I'm not going to go into all the metadata that is available, but there's quite a lot, and you can go read about it in the URL, which I can also share afterwards. This is the one I want to pause on a little while, because I feel this is a very good place to document your data quality standards. So as I said, a data contract is an agreement between the producer and the consumers. So if you as a producer can say, this is my output port, this is what I want to publish, and I will adhere to these data quality standards, then you can use tools and external tools to check. So just like you would do or have a legal person confirm whether a party is adhering to their contractual obligations, you can now use tools to automate the checking whether the data that you're receiving from this data product is adhering to the data quality that it has published in its data contract. So it makes things like automation and integration with other tools a real benefit. So I'm gonna extrapolate on that example in how this would fit into data quality tools and orchestration tools. So you can imagine, let's use this example again, where you have data quality tools like Great Expectations, Soda, or Monte Carlo. And because you're using a standard data contract, so it's based on standard, a specific standard, there's already CLI tools built for this. So you don't have to go and build your own tools and framework to interact with this data contract. You can reuse the CLI tool, which I believe is also open source and available online. And I know some of these tools already have some integration with it. I can't remember exactly what, but now you can, if you are the marketing leads conversion data product team, you can build checks and balances in place saying, I will only accept these tables from my input port if it adheres to these data quality standards in the data contract. And if it doesn't, I reject it. And I reject it because it's not adhering to the contract. The same with, or let's say rather, you'll put that probably more in the ETL tool. So when you build a pipeline, let's say in dbt, if you have a check in place that says, first check the data contract of the incoming data product. And if it doesn't adhere to those standards, I fail the job, I send a notification up the chain, and someone has to come and resolve that. So within data quality and ETL tools, I see a lot of benefit if you put as much information as possible in these data contracts, and not having these disparate tools, so like a one tool that has the data quality, one tool that you build in your orchestration, but you can stream, so you can even in your contract for your data product say what is the refresh rate that you're expecting. You expect the data to be refreshed at least daily, and then you can check if that is being adhered to. So how does this fit in with large language models? So I'm not, Johan, is that a new hand? Maybe it's...
Actually, yes, actually, Corné, actually, I just wanted to quickly to actually chip in just on the last slide,
yes.
or what you mentioned.
We have enough time.
Before we get to the large language model, just about the contract, actually, who is the owner of the contract, or the driver, or the person who is really responsible? The data governance team or the data architect?
I would say the data product owner of the producer.
Okay, the product owner.
Yeah, he's the accountable. I mean, you can.
Okay, but you see, because where we're going, actually, where I'm going to is these when there's actually problems and you're rejecting stuff. Actually, who do you that's the actually practicality. Actually, with escalating and actually who's essentially really responsible for it. Actually, that's where I'm just really getting to the actually practicality of it.
Yeah. Now, I would say that you can draw up a RACI matrix, but the accountable party should be the data product owner of the producer data product. And I say that lightly, but this is where the problem often lies. So you can imagine if you now decide to go with this foundational data product route, it's very nice in theory, but now let's take my example. Now the customer experience domain is the owner, and they would have an owner, a physical person that needs to be the owner. That person should be accountable for the data quality and the contract. They might not be the person that necessarily understands all the detail. They would have an architect or data engineers that implement these rules, but the accountability should be with the data product owner. But they would have a team that implements it and makes or designs it, etc. But I think if there isn't that accountability, or if the data product owner doesn't understand the responsibility that he or she has, then you will forever produce bad quality data products.
Okay, cool. Thank you. Actually, you've answered my question.
Yes. Yeah. And I can tell you in practice that the data products that function well are the ones which have proactive, present data product owners, not people that only turn up once a month to a data governance meeting, but the people that are weekly, daily, sitting in the stand-ups, planning sessions, etc. So it has to be a proactive role to be a data product owner. Okay, so just where does this fit into large language models and the demo that I showed in the beginning? We can, if there's some time left, I can jump into that in a bit more detail. So I've used the example from a company called Entropy Data, quite a nice little data catalog tool, which has these tools pre-built. So they have their own remote MCP server. Now, MCP is quite a new, because large language models and how it interacts with our data is quite a recent thing, the last couple of years. The architecture around AI, I think, will change quite a lot. So I'm not an expert, or I don't really have an opinion on where it will go, but I can imagine the architecture around interacting with your data will remain important, and there needs to be structure and a framework in place. I think otherwise you're going to lose control. So what I like about this is if you have this server, which you have these pre-built tools, and you tell it how to interact with your metadata and how to interact with your data, and using the information about your governance, then you can really scale when it comes to documenting purposes for the data request. So especially around GDPR and POPIA, how do you keep a proper audit log of people requesting data, why do they want to use the data, and also keeping track of how long they keep the data, etc. So not just for LLMs, but for any kind of interaction with your tool sets, from an AI perspective, I think building this backbone infrastructure will be quite important. But for a large language model, I, as a person, will speak in plain English terms to my large language model, where this is where the reasoning and the parsing of the query happens, and it sends it to real technical instructions. It will check these instructions against my governance policies. Am I allowed to use the data? Do I have access to the data? And it will try and figure out, based on the metadata here, what queries are possible. So the queries I showed in the demo in the beginning, it was basically checking which data products are available and seeing if it can figure out which potential queries might be useful. And I'll go into a bit more detail in a minute. So at the end of the day, it's simply reading the metadata about the output port. So it's seeing, okay, there's a fact table here and a couple of dimension tables. The metadata about these tables are documented and kept up to date within the data cataloging tool. And it will keep all of the information based on those 10 components, so the fundamentals, the data quality, and so on. So I believe if you have rich metadata about your assets, your large language models, and your other AI components, for example, agents that you have interacting with your data, will be able to have sufficient context. Now, this is a very big topic on its own. I'm only delving into the, let's say, the surface of it. But I think this will be a key component in the future. I don't think our data architecture roles will disappear. I think it will be augmented by how do we make it reliable for AI use cases. But I think it's more important than ever that we build robust frameworks in place, because it will simply become the amount of interactions from autonomous tools will just increase. And if we don't put the right context in place, it will start hallucinating on the data itself. So maybe just as a last few moments, what I wanted to show was I'm going to drop my access on another screen. I'm just going to quickly remove my access. So this is for me quite a nice illustration of how it can become useful. So if I give me 1 minute to update my access. Now you can interact with the LLM and it will explain to you, oh, sorry, you don't have access. Can I request access for you? Give me a second. Yeah, so let's just make sure by adding in. Yes, I still have access to the catalog itself. So it should be able to tell me which data products are available. Yes, I have a products, data product, website user behavior, and marketing lead. So that's based on the example I did in the demo. A similar question that I asked previously. Hopefully it will tell me I don't have access. Otherwise my demo has failed. There we go. Okay, so it's telling me that by reading the metadata, it thinks this fact table, marketing lead metrics, and the DIM product will be able to give me the result I'm looking for, but I don't have access. Okay, so please request access. Yeah, now, hopefully, I'm going to show you my other screen. This is Entropy Data. So I should see a new access request. There we go. That has been created. So what this will do is we'll create an access request, but for the data product owner, which I am the owner of everything in this demo, just to make it easy. But then if I approve the access, it will hopefully work. And what it should do is it will send the purpose for which I'm trying to do the query. So the data product owner will be able to see, oh, okay, Corné has been asking access. It's not some random intermediary. It is still my username. So my user is what is connecting to the Entropy Data MCP server. So it is using my credentials, asking the data product owner to get access, and it will be able to see for what purpose am I trying to get access. Obviously, if there's not enough detail, they will have to contact me or I'll have to contact them. But that would be the process that the data product owner is always in the loop and has to approve the access. Okay, so access has been approved, and now the query can run. So I want to show you that what it's the actual query that has run. So it finds that the marketing leads metric data product is the appropriate data product, and then it writes this query. So it figures out that this is probably a good query to run. It's counting the visit count, and it is also doing an additional sum on the total time spent, just to give me this number. So it looks decent. Obviously, the more context you can give in the metadata, the better it will be able to execute. But I didn't give really any context on how these tables should be joined together. What I did do is I made sure that the table names and the column names and so on had a nice standardized naming convention. So it was able to figure out, I guess, that these two columns can probably be used as an inner join, etc. So the other nice thing, but I'm not going to have time to show it now, that while I was actually preparing the demo, I had an issue with the integration to Snowflake. And it told me that there's an issue with the integration with Snowflake, and it actually also sent me to the help documentation of Entropy Data to go and figure out how I can do that. So I think that's quite a nice way in which I can see the future looking at if we just want enough prompts and enough context to be able to help us get to the right answer. And we will still have connection issues. We will still have authentication issues. But using large language models, it will make it easier to go and debug those things if you give it the right context and the right information to do so. Okay, I think that is the, oops, sorry, stop sharing. But if there's any other questions, now is the time.
Okay, thanks. Thanks, Corné. I'm battling with my camera. I'm not sure why it's not coming on, but yeah, open for questions. There were a few. I think Johan asked most of them, and I think it was predominantly around the data vault. So I don't know if are there any other questions, Johan?
Okay, sorry, I just want to get my boom in front of me. I think that first question I wanted to ask was just really about the domains and the contracts. Okay, because obviously your contracts, well, I would suppose gets actually does it get actually driven by your data governance or the architect and data governance?
So the data contract, I would say in a data mesh, the policies and the framework gets driven by the data governance central team. So it would tell you, they would give you the framework on how do you, let's take a real example, Calibra. How do you create a data contract? Here's the how-to guide on how to publish your data product, how to assign a data contract. But they just provide the framework. They tell you, oh, it's not ready. You don't have a data product owner. You don't have a privacy steward. You have personal data, so you need. So they are purely there to drive the framework and to stop you if you're not using the framework correctly. But your self-contained domain team needs to have all of the roles and people available to help you define the contract. So really the technical data engineers that will help you with the quality rules, the business analysts, etc.
Okay, thanks. I think, but the real question, I actually now remembered what I really wanted to ask, the Data Vault one, and the domains and the data product. So if you create a data product, which is something within a domain itself, actually, how do you, if you now do an enterprise or an enterprise data model, model, actually, how do you, because obviously there's going to be shared data and things like that. So how do you actually run that with these different domains and these data products, to keep it simple as in the way you describe now, to try and keep it simple? That's my real question I wanted to ask.
I understand exactly what you mean. I've seen some good examples, not physically myself, but in webinars and so on from other people. Maybe I'm not going to name drop them now, but maybe I can do it afterwards. But the first data mesh-like project that I worked on, it wasn't called data mesh because it started prior to 2019. We did it's still running, I guess, but we did a data vault as kind of the core. We have a raw data vault, and then we had the business vaults split, or let's say owned by the different domains or the different teams. And we decided that the raw vault will be owned centrally. So that would be one pattern where you, let's say prior to getting to the business vault, you still treat it as like a monolith. You have your raw data vault owned centrally. But I've seen some interesting permutations of this elsewhere. But yes, I think that is a very difficult thing to solve. I've seen about 3 or 4 variations of it. It's definitely possible. I don't think there is necessarily a best scenario. I see Remco's got his hand up.
I'm actually that. I also saw Remco can't wait to actually.
He's probably got a good couple of variations himself. So maybe I'll let Remco answer that one.
Yeah, thank you, Corné. Thank you, Johan. Just a quick response. Apart from, I don't believe so much in really role vault, business vault. So that's a completely different discussion, I guess. I worked actually for a company in South Africa, which was basically running a whole bunch of stuff in whole of Africa, and they used data vault just to make separations not only on domains but also on different countries. And every country was responsible for their own data and information, but by using data vault structure, they were also able to just connect all the dots between all the different business concepts they're using, because they were kind of the same. So I would say that if you want to go for data mesh, if you want to have 100% data product way of working, whatever the data product is, I agree with you on that one, Corné. Data vault is a perfectly fine example how to work, because you can just say this part of the data vault is completely assigned to this owner and this team. And because data vault, is completely decomposed, so every part is completely on its own, it's a very easy way to work for. Absolutely.
Yeah, so, I just want to add something. So I think as long as you can define boundaries, and I think in data vault it's easy because it is a highly normalized way, so it's easy to split and to create those boundaries between different domains. So yes, I also think it's a very good option.
And there are two things, right? So what they did as well, they call them squads. They had squad responsible for, let's say, a data product or a small piece of domain, but they also had the overwhelming squad. So those were the guys or the teams which are connecting the dots overall, the different counts overall domains, etc. And I think that's something you need to take into account. It's not just, hey, and I think it's the same with data product. Let's just create data products and that's it. You always need to have some kind of overview and some kind of standards to apply to.
Yeah, maybe
I agree with that. Yeah, that I've seen. That's a big problem. Which you have there isn't that overriding kind of an enterprise architecture or group or whoever, and that's where then everybody goes off on their own tangent, and then suddenly you've got like a real mess of a data mesh. If I want
exactly,
okay.
I mean, your question is triggering some memories because I think one approach. So often what happens in this discussion, you want to have a kind of unified view. So a big topic for another day, but you do want almost these foundational data products or these boundaries to mimic what your enterprise looks like. So real enterprise logical model, it should mimic that. However, you will always get stuck on who's going to build it, who owns it. So I think having a retrospective or a central team that ties the dot, and people talk about semantic links and things like this, I think is crucial, because you will, let's say the path of least resistance is to go with this bottom one, and you will end up with a plethora of siloed data products in a few years if you do not go through the effort of making sure there is this kind of connected enterprise view or enterprise data warehouse or a reusable foundational data products. You can name it so many things, but I think if you just simply always follow the path of least resistance, you're going to end up with a mess. And I think that is a reality in some organizations, but it's really a lot of effort to push back into this unified view.
Well, in Star Trek, they already said it, right? Resistance is futile. You will be assimilated. So we are all one complete environment. So,
So there was a question from Shane Corné, and that's how is a foundational data product different to the data modeled in the silver area?
It's just you can use, and I see this as well, but you can use medallion terminology within a data product as well. So it's not, it will probably start the debate about what is a medallion architecture really an architecture. I would say it doesn't have to be different at all. The thing that makes it different is a foundational data product is owned by a domain, whereas if you're just doing medallion architecture, you're not necessarily talking about data mesh. So it can be owned by IT, everything. But I don't think comparing data mesh with medallion architecture is the right comparison, because even not like, if you shouldn't be comparing, and I see this often on LinkedIn, people compare data mesh with data vault, or they're comparing third normal form with data mesh, and people are comparing the wrong things. Medallion architecture, and I agreed with Shane, it's kind of just a logical split of your raw data, your model data, and your consumer data. So you're right, the silver layer does feel like this foundational reusable data product, but I think you will waste time if you try to compare the two with each other. The one is simply a way in which you structure or which you logically split typically a monolithic approach to data warehousing, whereas if you talk about different types of data product, you are very much in the data mesh terminology. So yeah, I hope that made sense, but I wouldn't necessarily compare those two terms with each other.
Shane, any comment on your side?
No, that's good. Yeah, it's more trying to figure out. So, the idea that we had source data, data products, and then we got 5,000 data products. Then the idea of foundational ones came in the middle, which kind of felt like what we had in data warehousing, right? So if the difference is it's no longer owned by a central data warehousing team, it's owned by a decentralized domain-centric team outside of the data warehousing team, makes sense. It has data contracts, so anybody can use it without having to ask that team as long as it complies with the contract, I think. And then there's a product owner. There is a person who's responsible for that data. If those are the three things that make a foundational data product different to just a bunch of tables in a warehouse, then that makes sense to me.
You think you explained it better than I did.
So if I could just get some clarity on that side, that foundational product, it certainly can be made up of relational tables if you're going for third normal form. But what it has in terms of a wrapper, it has a contract and a way of accessing it via the output port. And then in terms of the input port, it will define where the data is coming from. So that YAML wrapper is bringing those third normal form tables together, and finding a way of delivering the foundational aggregated or consumer type stuff. It has a way of delivering the data to the person or the consumer asking for it. Is that really what that foundational data product is? It's a wrapped YAML file that's connecting these tables together.
Yeah, so I think maybe I'll say it like this. Technically, it can be exactly the same thing. It could be 3 relational database tables.
Yeah.
What makes calling it a foundational data product different is you're now adhering to data mesh terminology, which means it's a product, which means it has an owner owned by a domain.
Right.
The product has an output port, which are those 3 tables, and those 3 tables has a contract that it has to adhere to. So it's simply putting the data mesh governance framework on top of the same 3 tables. Technically,
it's really
still the same tables.
It's just a metadata layer on top of the actual data storage, right? So it's okay.
Yeah, but I want to it and everything that goes with that. The fact that you have ownership and
governance and all those the policies that get adhered in that situation.
Yeah.
Yes, Shane.
Yeah, I just wanted to say I disagree with your statement, Howard. I think the product is the YAML contract definition and the data set or the data assets that are part of that contract and the code that creates those data assets and the people, right? So those that's the boundary of the product. If one of those existing, if I take the code away, that product loses its value. If I take the data asset away, it loses its value. If I take the YAML contract API layer away, it loses its value. So for me, it's more than just that YAML file.
Yeah, but Shane, that then says that I can't include those 3 data tables in another product.
So you can access the data in that foundational product in your consumable product, but remember the owner of that foundational product has the right to delete it and decommission it whenever they feel like it, and then your contract will be broken and they have to have a conversation about this. So yes, we start getting this idea that products lose value, so they should be decommissioned or deleted, and then the consumer products are now going to have a problem, but the contract tells us that they were having a relationship, and that is a contractual agreement across those 2 domain teams. That's how I see it anyway. I'm interested in other people's views.
But what I was trying to, I suppose the question I'm having is, if the data is solely owned by that data product, and again, these are questions, are we then saying that 1 or 2 or 3 of those tables are not allowed to be involved in another data product?
They can be, but it's through that output port.
Sure, but that just means that the YAML or the data product is a meta definition. The actual ownership of the tables is not part of that data product.
No, so I don't agree with that statement.
But if I can include a table in another data product and it has a different owner, then who owns the table?
Because yeah, I might have missed that, but whoever that table, and again, as Shane said, the data, the contract is owned by one team. If it shares that table or that output port with another data product, it's still owned by the producer. The consumer is just using it because they have a contract between each other. If that table breaks, the contract was either violated by the producer. Well, that's the only reason. If the table no longer is usable by the consumer, it was because of a contract violation. And then, yes, then it's a conversation that is between the two different domains.
Okay, but I'm still not understanding. If I build a data product, all right, and it's got an output port, and then I'm going to build another data product, but it uses one of the tables in the other data that's used by the other data product, two foundational data products sitting next to each other. Is that not allowed, or is it a situation where I can do it?
Who built the tables? I would say if this team owns the tables, you can share it with it. Yeah, I maybe didn't illustrate that pattern, but this foundational data product can share its output with this foundational data product, but then it's still a contractual agreement between these two. But one table will not have or should not have two owners. It is owned by one. You can copy the code and do it yourself, but then you become the owner and you are solely. So this is what will happen here. You will build a table. This guy would build the same table.
Yeah.
But you don't have anything to do with each other. You're responsible for your own output and you're responsible for your own output. But I would say it needs to have one owner, and whoever creates it is accountable for what's inside that.
Okay, so I think what you are saying is if I need to access that data from another data product or that table, let's say it's got 3 tables, if I need to access one of the tables, then I should go through the other foundational data product to get access to it, not directly to the table that's seen in the bottom area here. Like I've got 2 data products going to 2 different API to the same API.
Yeah, you either trust the producer of that output, or you don't trust them and you do it yourself. And that's really the difference between the two approaches. So if you trust the other foundational data product, that means you are not grabbing it from inside there. You are doing it controlled by an output port, via a contract, via data quality rules, and you have an agreement in place. But, I mean, I do see this very often where the consumers or the 2 different teams do not want to talk to each other, not because they don't like each other, just because it takes too much time, budget constraints, whatever. It's normally for those normal IT reasons, not something more fundamental.
Okay. Shane? I'll come back to you.
I just want you, if I can jump in on that part of the conversation, Howard. So my understanding is other data products never actually go and talk directly to a table. They always go through the output port. So it's a complete change of behavior. You don't go scanning the database, find a bunch of tables and then connect to the table, because you're breaking the layer of the contract. And so you have to go through the output port, whatever that is.
Okay. All right. Johan?
Just really on sort of latching on to what you said, Howard and Shane, is I'm just a little bit worried about this fact, that say the foundational data product with their contract, if they can, or not break their contract, but they say, look, we're not going to actually supply that product anymore. But there are, say, 2 or 3 consumers actually using it. What would be actually, how can they, fight it or, tell the people, no, but you can't because we need that data or we need it to be redeveloped, so it's a slippery slope.
Yeah.
So what do you do in that instance like that?
I mean, I think that's a very plausible scenario. And like with any contract, again, between two parties, you have violated your contract if you no longer are publishing that data at that level of quality. So it is a discussion at the end of the day. Maybe you can ask the consumer to become the new owner. So they want to use that data. Now you have to build it. But
okay,
it will.
So
it
then
will
you have
be,
to be hard.
Well, I mean, this does happen.
Yep.
The reason I see it happen most often is because the producer didn't really understand what they were signing when they signed the contract, because they didn't really sign something. It's not like signing a legal document. They click a button on a data cataloging tool and they think they maybe don't understand that 20 different teams might be accessing their data. So I try to always tell the product owners, you know what it means when you approve a access request for kind of from a consumer data product. You become responsible for not just your own team, for all downstream teams that wants to use this data. It's a big responsibility. So I think that's more the reason why this happens, and it will happen. So it's probably making sure that the data product owners know the onus when they decide to actually create a foundational data product. And that's also one of the reasons why people don't want to do this. Is kind of what was my first observation, is people do not want to create foundational data products because it's not the path of least resistance. They want to be only responsible for themselves. So this really, for me, is one of the main challenges with data mesh is how do we build the incentives for people to build foundational data products? Because there won't be any incentives automatically.
Shane?
Yeah, I was going to add to that by saying, a number of times I've seen a large organization where the data warehouse team have built some tables, an analytics team, so analytics team 1 have built some additional tables on top of it. Analytics 2 have been connecting into Analytics 1's tables with no permission, no understanding. Analytics 1 go and refactor their code or their tables and break Analytics 2's team's work. And now somehow Analytics Team 2 think they have a right to get Team 1 to change something. But there was never an agreement. There was never understanding that it was multi-use. So for me, like you said, that idea of a foundational one with a contractor saying, we agree that this is a reusable product, that we expect other teams to use it. We will do that extra effort to honor that contract. That is the conversation that should be had. But like you, I see lots of companies just go in and treat it as a technical problem, not a policy, procedure, teaming problem. And that's why they don't tend to get the value out of it, in my opinion.
William?
So one of the things that we did in the UK was we piggybacked off control in the technical space, and we brought data into it. And what that meant was that if anybody was going to do any kind of a technical change to any part of the systems, they would have to then consider and get sign off on the data. And that then was a mechanism whereby we had to then create an earlier version of the change control to deal with just with the data and the data products and manage that from there. That ownership was the biggest issue, to your point, Corné. And that meant that we had to get business data owners who had to sign up for it. And as became part of their job description, part of their handover. And that's the way we managed to get that to work. Nobody was allowed to create anything that was not going to be owned. And all of your Excel spreadsheets had to become business developed applications with code written into your first sheets and as well as who the owners were, etc., etc., etc. And so a lot of the managers said, I just don't want this trouble. We would rather go through the data warehouse or something else, but I don't want to carry the load of this thing on Excel. And so we managed to reduce that a little bit, but we had to create these additional governance things. And we had some really clever people that recognized the challenge. And I think that's where the problem comes in. If you don't have that governance cleverness amongst your senior subject matter experts that have clout and power, you're going to struggle with that.
Great. Thanks, William. Any other questions? We're on 5:30, 7:35. Any other questions? Corné, I'd just like to thank you before we end. Thanks for the discussion.